This is our third type of application problem using rational equations. This one has to do with distance, rate, and time. So it says recall distance is equal to rate times time. Think about it. How far you can drive in a day on a trip depends on how fast you're going and how long you drive that speed. So if I wanted to solve this equation for t, I would divide both sides by r, and I would get t is equal to distance over rate. We're going to use that in this problem. So let me read the problem to you, and then we're going to talk a little bit about some things you need to know in order to solve one of these. A paddle wheeler goes 10 miles against the current in a river in the same time that it goes 15 miles with the current. If the rate of the current is 3 miles per hour, find the rate of the boat in still water. Sounds like a lot of words, doesn't it? These kind of problems are very formulaic, however, and they all work the same way. But there are some basic understandings you need to have. So, pardon my artwork, but here you have a river, and here you have a current at a certain rate. In this case, it happens to be 3 miles per hour. In your boat, all right, this is supposed to be an engine, okay? I know it's out of the water, but whatever. If your boat is traveling in the same direction as the current, in other words, with the current, then the total speed of the boat is going to be the actual speed of the boat plus the speed of the current, because the current is pushing it along. Now let's do another scenario. Here's the river. Just know that my artwork is not going to be getting any better than it was just a second ago. The current is still going that direction. Now you're in your boat. Let's try to put the engine below the water. But this time your boat is traveling this direction. So it's going against the current. So in this case, the total rate of the boat is going to be the boat's speed minus the speed of the current, because this current is slowing you down. So these are the two scenarios. When you're going against the current, this is the actual rate. And when you're going with the current, this is the actual rate. And that's kind of an understanding that you have to have in order to work these problems. So now let me show you how you set up all distance, rate, and time problems. You draw a chart, and that chart is going to look something like this. And in this cell, we write distance equals rate times time. That's how we label the horizontal cells going across the top. And then we have two things going on. We have you traveling with the current, and then we have you traveling against the current. All right? We are going to establish that what we don't know is the rate of the boat. So we're going to say, let B equal the rate of the boat. And when it says in still water, that means without the current, if there were no current. So let's fill in the cells that we know. We know that the distance that you go with the current is 15 miles. It says so right there. So I'm going to put a 15 here. The distance that you go against the current, it says it goes 10 miles against the current in a river. So it's 10. With the current, just like I showed over here, your total rate is going to be the rate of the boat plus the rate of the current. So it's the rate of the boat, which we don't know, we call B, plus the rate of the current, which we do know. It's 3. Against the current, your total is going to be the rate of the boat minus the rate of the current. Rate of the boat, which we don't know, is B, minus the rate of the current. Now I have 4 of my 6 cells set up. And the key to this problem, well, other than getting the rates, are these next 2 cells, because it says that it goes against the current in the same time, meaning these 2 times are equal to each other. the time going with the current, we're going to use this formula. The time with the current is the width distance over the rate that we have going with. So time, remember, is equal to distance over rate. So I use that distance divided by that rate. In the same way, the time going against is its distance, the against distance, over the against rate. Now we're ready to set up an equation that we can solve. So the key to this is getting this chart set up. So what we say is we know that the with time, with the current, is equal to the against time. Well, I have those representations right here. So the with time equal to the against time. And now what I have is a proportion. So this is similar to the application problems using proportions. It's just the setup took a lot longer. We're going to use our cross products, being very careful to know that we're going to be distributing. So I'm going to put parentheses there. So 15 times b minus 3 is equal to 10 times b plus 3. Those are just my cross products. Now I'm going to distribute. 15b minus 45 equals 10b plus 30. I'm going to get variables on one side and numbers on the other. So I have 5b minus 45 equals 30. Add my 45. I get 5b equals 75. Divide by 5, and I end up with the rate of the boat. 5 into 75 is 15 miles per hour. 15 miles per hour. So that would mean that when it was going against the current, it would be 15 minus 3, or 12 miles per hour. Problem didn't ask that. I'm just showing you. And when it was going with the current, it would be 15 plus 3, or 18 miles per hour. But the answer that we're looking for is right here. The rate of the boat is 15 miles per hour.